2, if you don't have all the evens attempted in homework 3, remember I did say technically. We talked about prioritizing, we talked about wise versus foolish procrastination, etc. Some of you might need to catch up this weekend, but there's no football game tonight, praise the Lord, right? So that's a good thing. Because a lot of you either need to or choose to stay up late on Fridays, and then Saturdays are rough. So hopefully we can get more done this weekend than even usually. I'm actually not starting with the overhead. I don't know why I just did that. Sorry, we're coming back to it. Let's start in the smart board, since I have it all nice in the line. We talked about what clues yesterday? Critical numbers, critical points. Now remember, on the AP, you have function graphs and you have derivative graphs. There are 2 different cards that have graphs, right? You look at the graphs differently because, right, if you have an original function graph and you're trying to find critical points, where are you looking? Mins, maxes, wherever you have, if you are skimming with little baby tangent lines, right, your little handed tangent line, as you're skimming the graph, you're looking for where it goes flat, where it goes straight up and down, or where it's sharp. True? Okay. When you're looking for critical numbers, you're looking for where it's flat, where it's straight up and down, or where it's sharp. Okay, those are critical points on a function graph. But how do those show up on a derivative graph? You guys just wrote it. What are critical numbers? F has to exist, okay, and then F prime equals what? 0 or, oh goodness, you just took it, and I just told you the answer before you took it. Hold on, critical numbers. What does the derivative need to equal? 0 or D. I guilt you into that one. Come on, guys. Good thing it's fun. So coming back, zeros are D and E's, right? So on the graph of the derivative, how do you see zeros of a graph? Intercepts, right? That's pre-cal. That's algebra 1 stuff. But we have so much, when you start putting like more complicated stuff in, the easier stuff gets harder. So just think, okay, zeros, that means x-intercepts of the derivative, and then D and E's, those are going to be like maybe vertical asymptotes, maybe holes, maybe breaks and jumps. Okay. The next clue we talked about was, remember there are also those descriptions with words? You're going to see things like absolute extrema maybe, or relative extrema maybe. And we reminded ourselves that even though this is an absolute max, what else is he? He's also relative. He's absolute and he's relative. That's just relative because he goes lower. That's just relative because he goes, well, higher technically, I should say. Right? So absolute versus relative extrema, quick reminders of what those look like. Points of inflection. This is the last thing I think I wrote yesterday. Points of inflection. How do you see points of inflection in a function graph? Concavity changes, right? So in a function graph, it's just the points in between concavity changing. Once again, this could show up in the description especially. And we're going to learn more in section 3-4, points of inflection. We haven't talked about concavity of the graph yet as far as how it relates to derivatives. But if we're looking at a function graph, a point of inflection is a point between which, or at which, I should say, a function changes from concave down to concave up, or concave up to concave down. And if you notice, it's not necessarily anything super special about the derivative, because this one, the derivative is negative because it's sloped down. This one, the derivative is approximately 0 because it's pretty stinking flat. And this one is positive. Huh. I don't think concavity changing and points of inflection are dependent on F prime. They kind of are, but they're more clearly dependent on F double prime in that section 3.4, which we understand. But points of inflection, points in between which concavity changes. You guys have those ones? Okay. I had one more page of clues, and that's what I was using a lot yesterday to help us kind of just delineate things, just kind of spread them apart and see what's going on, and that's a sign chart. All right? If you're looking at a function graph, at an F graph, right? Critical points to put into the sign chart are going to be found. We already talked about critical points at the relative extrema, relative mins, relative maxes, any other places where I have a flat tangent, an up and down tangent, or a sharp point. And I'm looking at a function graph. Relative extrema, sharp points, straight up and down tangent lines. Those will tell me what numbers to put in for my critical numbers. If I'm looking at an F prime graph, critical points, the zeros, the vertical asymptotes, the jumps, those are going to tell me what to put in. But once I figure that out, right, I figure that out? To fill in a sign chart, I need to think about what's going on. Remember, when we're thinking about F, we're thinking about how F is changing or moving, which is going to be F increasing or decreasing, right? When I'm thinking about F prime, what am I trying to think about?
Positive or negative.
Positive or negative. Nice. And if you think in a sign chart, it might help you kind of think through some of the clues, some of the pieces of information, some of the graphs that you're looking at, etc. So if you can analyze the behavior, that'll help. Now, in order to help us with this, before we go back and we'll make one more match, we filled in one entire row yesterday, right? We filled in one entire row yesterday. I think it was was it 16? Okay, number 16. We'll do one more today, but first of all, I have an example if I can find him. He was actually for later, but we're ready. Ooh, we're almost ready to face him. Let me copy this. We're ready to do A and B. We're not quite ready to do C yet. But let me go ahead and throw him in. Okay? Let's do an example. So who is this the graph of?
F prime.
F prime. Okay, remember yesterday we looked at the graph of F, we looked at the graph of F prime. They required kind of different reasoning or rationale. Remember, we don't exactly know how to do inflection points right now, so let's just wait on that. All right. This could be one of your function graphs. It's not exactly, but it could be one of your function graphs, and you have to match it. Ah, not a function graph. Lo siento. Oh my goodness. This could be one of your derivative graphs. There we go. Okay, focus. This is one of the most common AP questions on an FRQ.
I got it.
Okay? Okay, focus on it. So I have a graph of a derivative, right? Guys, focus. Come on. I'm proud of you for being here. We've got to focus. This is a graph of the derivative, right? As I look at the graph of the derivative, am I asking myself increasing, decreasing, or am I asking myself positive, negative?
Positive.
Good, right? Sign chart. Positive, negative. Now, hold on. Before I go to positive and negative, I need to put in critical numbers. Okay, hold on. If I'm thinking critical numbers, am I thinking mins and maxes of him, or am I thinking zeros and DNEs? Good, right? We just have to connect things. Very good. Go ahead.
There's a phi sitting in your head that's got that.
Oh, thank you. Thanks for looking at it. That was close. All right, so coming back. Coming back. I'm looking for zeros and DNEs. All right, what zeros and DNEs do I have? Okay, I kind of cheated because I marked those points and didn't mark the other ones. But do we see why we're using those ones?
Yeah.
Not because he's a max, because he's a zero. A zero of a derivative is a critical number. Not because he's a, I don't know, something. But because he's a zero and not, whatever. He's a zero, right? Does he have any DNEs? No. Why? Well, there are no vertical asymptotes or jumps or holes. Okay, well, we just took all the zeros. Critical numbers in the sign chart, check. What do I ask myself to fill in? What did you say I'm looking at this graph for? Positive, negative, or increasing, decreasing? Positive, negative. What am I asking myself to answer the positive, negative question for this interval up here in this graph? Above or below? Is he above or is he below? So therefore, negative. Woo! That's right?
Yeah.
Go to the next interval. Above or below? Nice. Negative. Next interval. Nice. Next interval. Sweet. And so if I needed to, couldn't I say F is decreasing for that interval, decreasing for that interval, increasing for that interval, decreasing for that interval? So question, where should there be a relative min?
Critical number 1.
Critical number 1, aka x equals 1, right? Why? Because my function's going to do, I don't know exactly how, but some sort of increasing, then, some sort of decreasing, then increasing. There's a horizontal tangent in between. There has to be a relative min. And he's going to do some sort of increasing, he's going to do some sort of decreasing. There's a 0 in between, so what's going on at 5? A relative max.
And then I think the negative and negative is the vertical line. Would that be right? How's that work?
Well, it's no, because it's going to be horizontal. So it's going to be decreasing,
And then
flatten, decreasing some more.
Is that a point of inflection?
I guess maybe that's where my minimum should be. There we go.
What
Yes,
is
that will be a point of inflection. So then if we were graphing up here, now guys, I don't know exactly where this guy is, but I do know for some way, since the derivative is negative, my graph is going to be somehow decreasing. It's going to flatten. There's the flat at 1. Decreasing some more. At 1, it's going to start after 1. 1, it's going to flatten. Then it's going to start increasing. It actually increases quite a lot. Then it starts decreasing. And I'm done. Okay? Now, this little graph that I just drew, it could be up here. He didn't connect. He could be up here, right? And he would still be doing the same increasing, decreasing. He could be down here. He'd still be doing the same increasing, decreasing. I can't say exactly where he is unless they give me some point on this graph for me to like stick it and then be able to go from there. But I do know roughly what the original function should look like based upon, it's not going to work so well, based upon my sign chart. Hold on. So there needs to be a flattening at -1, decreasing before, decreasing after. There needs to be a flattening at 1, decreasing before, increasing after. And then there needs to be a flattening at 5 and then decreasing after. All right, that's roughly my app. Wherever he may fall, whether he's up or whether he's down, there it is. Okay, so let's see if we can make one more match. You guys ready? You want to get out AP number 2? That's a great idea. Where's my pushy button?
Can somebody leave their pencil with the notebook, guys?
I'll take the pencil.
Thank you.
Wants to claim the pencil that was left with the notebook of putting down groups?
Thanks for the free pencil, guys.
Awesome. It's a good morning. Oh, here's my pushy thing. Okay. What function do I have up there? 1. Okay, so draw that sketch in number 1. Remember we draw little sketches in the little boxes with the numbers? Aw, I did. Oh, I think it's back. Nope, I didn't help.
Oh, it's moving. What if you jam paper in the sides by the more friction?
We'll just figure it out. It's not going to take long. Okay, what's the first match we're trying to do? Description. Okay, let's go fast. There's a 1, there's a 2, there's a 3, there's a 4. I know we already made one match with it, but that's okay. You're going to have 16 of these all together and you're trying to figure it out. It's not H. Doesn't have 2 relative extrema, right? Okay.
It's I.
It's I? Why isn't it K?
How do you read so fast?
K says it's a line. That's not a line, it's a parabola. That's silly. Okay. 4 critical points. No. How many critical points does he have? 1, because he's a function and he has 1 maximum. He has 1 flat tangent line. Alright. So 1 critical point? Does that sound good? And there's that 1 critical point. Okay. What's next? Judging. Okay. Ooh. There's 1. There's 2. There's 3. There's 4.
So it's increasing and it's positive. If it's decreasing,
Increasing, so you need to have an above derivative, a 0, then a below derivative.
it's x bi. It's 15. It's in
14? 16? Because, number 1, if you just think about degrees, can a parabola have a quartic derivative?
No.
That doesn't make sense. Forget that. Can a parabola have a parabola derivative? No. Quadratic has to go down a degree. But if you want to think about it also, there's only 1 0. So question, how many intercepts should the derivative have? Not 4, not 2, not 0, but 1. This is the only one with 1 intercept. That's one way of looking at it. Brandon was saying the function's increasing then decreasing, so the derivative should be above and then below. Ooh, that's nice. And then if you think about the power rule, a quadratic should have a derivative of a line, right? Bring down the 2, make it a 1, the degree is now a 1. Bingo. Who would have a derivative that looks like this?
A line. Is it constant?
Yeah, give me an example of a line.
X.
2x, because then the derivative of 2x is 2, and if you look, there's a little baby arrow, and this must be positive somebody. Hey, that's positive, sure, why not? Could be 2, could be 4, could be 3, could be whatever you need to be. All right. One more match, right?
Yes.
What do we need? Derivative description. Oops, I guess the last one was negative 2, not the last one 2.
I'm calling it M.
Because this one I have negative in the middle and positive on the sides. Well, that doesn't work. He's positive then negative. Okay, no. The derivative is 0 lots of places. Nope, he's only 0 once.
Yeah.
The derivative is always negative 2. Wouldn't that be a constant function, like a flat line? There we go.
Yeah.
Okay. Now, we did 2 out of 16. You have 14 more to go in your groups. My notebook, did it end up somewhere? If any of you guys don't have a group, feel free to drop by after school, and then we'll try to, well, hold on. Maybe I'll work on it during class as we do some notes. Yeah. Bridget is so excited. All right, AP number 2 hints done. Go ahead, get your spiral. If you have homework attempted, maybe you don't have all of it attempted, but let's check the evens that you do have attempted. I did have some people talking yesterday about how on my website, under helpful links, I do have, or additional resources, or whatever it's called, helpful links, I do have something called a derivative calculator program, where you could check your derivatives and make sure that you're finding them correctly. Get homework on, especially on the evens that are not working out, maybe your derivatives. Now, some of it is writing the derivative correctly in the sense of nicely simplified and a nice fraction to make a pitchfork with, et cetera, et cetera. But some of you might just be getting wrong derivatives and it's messing you up. Command strips are only so strong. Okay, here we go. We're going to section, we'll do that on Monday when actually more people are here. Let's go here. There we go. All right, you guys have homework before you. What's our first even? 6. Final answer on 6 is no. Hold on. Wait, is this how we show it? Why not? Wouldn't this take forever? Okay, so you guys shouldn't be using CalcChat to do the answers because you're taking way longer if you're following them. But long story short, you should be able to match up your arrows with the intervals. From negative infinity to negative 1 would be decreasing. Negative 1 to 0, increasing. 0 to 1, decreasing. 1 to infinity, increasing. Cool? Number next one. Increasing, decreasing, decreasing, increasing. Your critical numbers should have been 0, 1, and 1/2. Sorry, 0, 1/2, and 1. But you can, remember this will be recorded, you can check on the video and make sure your derivative is right, but you can also be using that derivative integral online to make sure that you're finding the derivative correctly as well. Sorry, derivative calculator online. Critical numbers, 0, 1/2, and 1, increasing, decreasing, decreasing, increasing. Number next one. Critical numbers, 0. Nope, discontinuity at 0, sorry. Critical numbers, plus or minus 3, and there was a discontinuity because x cannot equal 0. Careful, you might have forgotten that entirely. So those 3 get plugged in, you get increasing, decreasing, decreasing, increasing. Huh, sounds like the last one. Increasing, decreasing, decreasing, increasing. Number next one. Letter A, you're just finding critical numbers. Hey, isn't that just like doing the process? 0 to 4. Letter B, you're doing a sign chart. Increasing, decreasing, increasing. And they wrote it all nice and pretty the way you should have too. Oh, they're using commas instead of U's? Whatever. Slackers. And then, ooh, this is relative extrema. We can say if it's going up and down, hey, that must be a maximum at, oh, wait, why are there two numbers? They took the x and what did they do? They found the points. They found the y value. So they're finding the x and the y. So it is at x equals 0, but they went back, I think they asked for the points of the relative maximum minimum. Go back, find the y. There we go. And then relative minimum is going to occur at 4, negative 17. Remember, next one. Remember, if I'm going too fast, just check out the video online this weekend. Critical numbers, negative 3 and 1. There was also, a discontinuity at negative 1. Throw them all in, increasing, decreasing, decreasing, increasing. Oh my goodness. This is like all the evens. And you end up with those intervals and a relative maximum of negative 3, negative 8, and relative minimum of 1, 0. Remember, these are only 1 each. At negative 3, at 1, they just found the y's. Remember, next one. Critical numbers, negative 1, 0, no discontinuities, because it actually ended up matching at negative 1 at the separator. Increasing, decreasing, increasing. You have your intervals. And then relative min at negative 1, relative max at negative 1, relative min at 0. Guys, I did a piecewise in notes. If you're getting confused or if you're going to get confused, check out the notes. There's an example. Remember, next one. Ooh, look at that. Did you get him? You're trying to get the derivative function. So he's going to be a constant because the other one was a slanty line. Then you guys had number 80. We had a 4th degree. It's going to be a 3rd degree. It's going to be a positive 3rd degree with little zeros at negative 1, 0, 1. I don't know where we're going next. 88. Oh, these are the little inequality ones, right? 88. Final answer, less than. Wait, you only had 88? Oh, okay. I thought I gave you more of that. So 88 is less than. Number next one. How do you find the velocity? Take the derivative. How do you find the positive and negative directions? Make sign charts and you end up with where the position is increasing and where the position is decreasing. That closed interval might be tricky. The reason why is at 0 the velocity is negative. Struggle. And then it changes direction at 7/2. Any more? Nice. Alright, kiddos, it's all on the video if you need it. I'm getting rid of that, and we are starting section 3-4. The nice thing is, 3-4, oh no, it's another characteristic. We just did increasing, decreasing. Now we're going to do concavity. It's going to be ridiculous, except we're not that new. You can get through 3-3. You can get through 3-4. We just have to add a few things. You can get through 3-3. You can get through 3-4. We just have to add a few things. So the nice thing is 3-4 is going to be really, really, really similar to 3-3. That's nice thing number 1. Nice thing number 2, we are not finishing this section in the next 8 minutes. But for those of you that are like, wait, I'm caught up, you could probably get a lot of this homework done just by seeing the first few things I'm going to show you. Because it follows the pattern of 3-3 problems. It follows the pattern of 3-3 problems. We're still doing a sign chart. We're still kind of doing steps 1, 2, and 3, but we're just making different conclusions because we're not doing a sign chart of the first derivative. We're doing the sign chart of the second derivative. So for section 3-4, analyzing functions for concavity, we're doing a sign chart, but with the second derivative. We're finding zeros and DNEs of the second derivative. We're finding positive and negative of the second derivative. And it's telling us about concavity of the original function f. And then we're adding one more step in the second half of homework like we did with relative extrema before. We're adding one more step to find points of inflection. Points of inflection always happen when sign changes of the second derivative. And then at the very end of homework, or the last big idea is you can actually figure out if something is a min or a max, a relative min or a relative max, with the second derivative also. Does not sound like 3-3? But what's new? Second derivative. Oh. And what it tells us. So, really quickly. page is kind of intro. Usually when you think of concave up, you think of concave up like a cup. There we go. Someone remembered something. Concave up like a cup, right? So, that's concave up. The question, what else is concave up? That. But it's only half. I don't care. It's concave up. Why? I'll explain in a second. But it fits more like a smile than it does a frown, right? If someone's face looks like that, well, they have a crooked smile. But either way, it's the smile, not a frown. Maybe it's a smirk. Okay, what if it's like this? Isn't that concave up also?
Yes.
No, it is, because look, it fits. See? If it's concave up, it doesn't fit concave down. So all of these are different concave up pieces. Oh, those are stuck together. Anyway, these are all concave up. That's concave up, that's concave up, that's concave up. Oh, really? Mm-hmm. So what's concave down? Concave down like a frown. That's a full concave down. But guess who else is concave down? That one. Guess who else is concave down? That one. Why? Even though it's only, in a sense, part of the concavity, it still fits the concave down pattern. Right? This is definitely not a smile. If someone's face has that as part of it, it's not concave. Okay? So all those are different graphical representations of what it means to be concave up or concave down graphically. However, what's actually going on? Anyway, at the very bottom, what concavity does this have? Even though it's not a cup entirely, filled with weak water, but it's concave up, right? Okay, what's that one? Concave down. Okay, so wait. We can label them really quickly. Hey, this guy's concave up, and this guy's concave down. But what's the question that's being asked? Analyze how are the slopes changing? Wait a minute, slopes? What on earth does concavity have to do with slopes? Because look, concave up has a decreasing and an increasing portion. Oh, well I guess increasing, decreasing doesn't tell me what concavity it has, because this one has an increasing, decreasing portion also. Or it's just increasing, or just decreasing, or just increasing, or just decreasing. Increasing, decreasing does not help me for concavity. At least increasing, decreasing of the function doesn't. But wait, on a concave up portion, what are the slopes doing? Okay, so hold on. Slopes are increasing on this concave up. Let's go try another concave up. What are the slopes doing on this one? Here's where it gets tricky. Increasing means going more positive. Ooh. This is a high negative number. Why? Because it's really negatively steep. A high negative number is where on the number line?
Somewhere.
That way. If it's getting less negative, going towards 0, what's it doing on the number line towards 0? Increasing. Now, it's tricky because the slope is getting flat, which means the speed might be decreasing. But the velocity, the number, numerically, the number is increasing. Oh my goodness. So slope is increasing on this one, and slope is increasing on that one. I think it has something to do with slopes. And what's going on in concave down? Big positive number line over here. Going towards 0. What's it doing? Decreasing, right? Okay, hold on, but what about this one? 0-ish, going more negative. What's it doing? A higher negative number, which means it's doing what on the number line? Decreasing. So, all of concavity can basically be described by what F prime is doing. I know, look at it. It's so nice and pretty. Concavity test. Concavity test. Wait a minute. Where did F double prime come in? I don't get it. Wait. Increasing, decreasing. F was increasing when his derivative was positive. So when will F prime be increasing? When his derivative is positive. What? What's the derivative of the derivative? F double prime, the second derivative. So it follows basically the increasing, decreasing test. So if f prime is increasing, that means his derivative is positive, and both of those point to the original function, little guy that got left in the dust down here, he has a concave up, of course. So now there's an extra characteristic. If f prime is increasing, f double prime is greater than 0, f is concave up. If f prime is decreasing, his derivative is negative, which comes back to the original being concave down. And if f double prime is 0, then f is constant, and f has a possible inflection point. I'm going to quickly zoom out and get a rounded rectangle, making yellow. Come on, you guys were expecting it. Even before Ryan said something. Forever number 26, hence why it was good to have the forever quiz today and not on Monday. Ooh, there would have been another one. Now hold on, pause, pencils down. Why? Maybe just a few of you could not only get caught up on 3.3, but start on 3.4. Can I show you the steps for analyzing concavity? Which is just like the steps for analyzing increasing.
That's not a forever part, is it?
No, but wait. Does this look familiar? Discontinuities. Oh! Pitchfork. Wait, but of who? Oh! And a sign chart for who? Oh, you use these and these in a sign chart, and then you find the sign of who? And what does that tell you? The conclusion, positives and negatives, weight of f double prime tells you concave up of f or concave down. Okay, let's get out of here. We're going to keep on working on Monday. We're just going to like zoom into 3.4 and go, 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 go. Yeah.
Can I come in here and
Yeah. If you guys are worried about groups, pop on in during lunch and I can peek, and maybe some of you guys can put your group together if you don't have one yet. If you guys are worried about groups, pop in during lunch. I'll figure it out if it doesn't have one.
Sorry, Jacob, but I know. But they found their option.
Hey, you said number 22
I'm ready
Tuesday?
for that.
Right? Tia, she said that? She said number 22 Tuesday. Homework number 1. Is it due Tuesday?
Tuesday or Wednesday.
Cool.
Maybe we can get as much done as
This
I
is
can.
enough to do it Sunday. Oh, someone left their calculator. Jason!
I got my gym bag.
Hey, do you want to hold this calculator? I don't know.
Wait, are we moving on today? I think so. Because my sister said she's definitely in her times. Yeah. I know. I'm supposed to be like a non-work Sunday.
Are we starting chapter O?
Yeah, we're starting. Wrong seat, Ben.
Oh. Wow, great.
It's a Friday.